Okay, so today I'm going to walk through the insertion sort and basically how it works. And so basically the gist of insertion sort is that it divides the array into two parts, one of which is unsorted and one of which is sorted. And the sorted part will grow each iteration until eventually the entire array is sorted and your sort is complete. So let's kind of walk through how insertion sort would look through this random array. So first we have a sorted part, which I'll put here. Alright, so our sorted part I'll mark is here, and then the rest will be unsorted, so kind of like this part. All that is unsorted. So the 3 is already sorted, it's in the right place, since any array of size 1 will automatically always just be sorted on its own. Okay, so that was that interesting. So now we're gonna grow the sorted size to 1 by 1. So now our sorted array is going to be these 2 values instead of just the 3. And then it just so happens that the 9 and the 3 are already in the correct places, so you don't really have to do any swapping or anything. So now we're just going to move on to the next iteration. So now we got to really look at this because the 1 is not in the right place. So what we need to do is we need to swap this 1 over to the beginning and then move everyone else over. So the 1, 3, and 9 are all in the right places. So now, once we do that, let's see how that would work. So now, after this swap here, our new values are going to be 1 here, 3 here, and 9 here. And then there's a loop that would implement this exact swap. And then now our sorted portion is this size instead of, now our sorted portion is of size 3 instead of size 2. So we're just growing our sorted portion 1 by 1. And then for 13, it's going to work exactly the same way as 9 did, since it just so happens that 13 is the largest value, so it's going to be automatically sorted. So that is good. So let's see. So the next step really isn't that interesting. We're just going to grow the sorted portion by 1 now. So now our sorted portion is size 4. And then we have our 4 unsorted over here. Okay, so now let's look at 10. So 10 is larger than 9, but less than 13. So we need to find a way that that moves 10 over by 1, but not any farther. So basically what we need to do is we just need to swap these 2 values in order for all of them to get in the right position. So basically it just compares, okay, is 10 less than 13? Yes, we'll move it over. Is 10 less than 9? No, so we just kind of stop it there and keep going. And so basically now, after we do that sort, our new array will look like this. So the 13, the 10 will be here, and the 13 will be here. Cool. So now our sorted array is of size 5 instead of size 4. I'm going to copy that first. So now our sorted array is of size 5. So the first 5 values are sorted. Okay. Cool. So now... Okay, so, and then let's do it again. So now let's see. So now we're looking at 6. So 6, what we're going to do is we're going to move it from 6 all the way. We're going to move it from the 6 to this position, since 6 is greater than 3 but less than 9, so 6 should go where 9 is. And then just move everything else over by 1, so everything's in the right position. So basically how that would look now is, let's see how that would look. Let's move everything over. Okay, so now the 6 would go here, the 9 here, the 10 here, and the 13 here. Okay. And now our sorted portion is of size 6. So all this, we're just growing our sorted portion. And then this process will just complete, and then again with the -3, we're just gonna move -3 all the way to the beginning and then move everything else over by 1. And that, again, kind of the same process. And then with 4, we are going to, so now our order is going to be -3, 1, 3, 6, 9, 10, 13, 4. And then with 4, obviously we're going to just follow the same process. So 4 is between 3 and 6, so it's going to go where 6 is now. So we're just going to pop it there and then move everything else over by 1. And then now the entire array is sorted. So now after we do that final swap there, our final array will be -3, 1, 3, 4, 6, 9, 10, 13, which is what we wanted, which is good. So now we have our sorted array. All right, so basically the algorithm structure of this sort is that there's going to be an outer loop that will basically kind of move the partition over by 1 each time that the loop runs. So it'll basically change the size of the sorted portion of the array. And then there'll be like a smaller loop with some if statements and stuff that will like actually like compare values and swap if appropriate. And like that's kind of what you need to do for the homework today. So that's kind of the basics of insertion sort. So yeah, hope that's helpful and good luck on the homework.